morning, this is Romel Magcalas, your subject teacher for statistics and probability. For today's lesson, it is all about basic concepts in testing hypotheses. Hypothesis testing can allow us to measure data in samples. To learn more about the data in populations, that are often too large or inaccessible. We can measure a sample mean to learn more about the mean in a population. Here, we can either accept or reject our assumptions using hypothesis testing. This module in hypothesis testing will help you study the different concepts and steps in hypothesis testing, as well as its application in real-life situations. After going through this module, you are expected to: Number 1 is to illustrate the following: A. Null hypothesis. B. Alternative hypothesis. C. Level of significance. D. Rejection region. And last, types of errors in hypothesis testing. Number 2 is to identify the parameter to be tested given in real-life problem. And last, to formulate the appropriate null and alternative hypothesis on a population mean. Hypothesis testing is a statistical method applied in making decisions using experimental data. Hypothesis testing is basically testing an assumption that we make about a population. The hypothesis is a proposed explanation, assertion, or assumption about a population parameter or about the distribution of a random variable. Definitions of statistical hypothesis: a premise or claim that we want to test. A statement about the numerical value of a population parameter. A statement or tentative assertion which aims to explain facts about the phenomenon. Lesson 2. Two types of hypothesis. The null hypothesis is an initial claim based on previous analysis, which the researcher tries to disprove, reject, or nullify. It shows no significant difference between two parameters. It indicates that there are no changes. It denoted by H sub O. The null statement must always contain some form of equality: equals, greater than or equal, or less than or equal. The alternative hypothesis is contrary to the null hypothesis, which shows that observations are the result of a real event. It indicates that there are changes. It is denoted by H sub A. It contains not equal, less than, or greater than symbols. For example, if the null hypothesis is equal to some value, the alternative must not equal to that value. Presentation of the various hypotheses in relevant pairs. As a mathematical convention, null hypothesis always has a symbol with an equal in it. Alternative hypothesis never has a symbol with an equal in it. The choice of symbol depends on the wording of the hypothesis test. Example number 1. The average monthly income of Filipino families who belong to low-income bracket is 7,500. Null hypothesis for this example: the average monthly income of Filipino families who belong to low-income bracket is 7,500, or mean is equals to 7,500. While the alternative hypothesis for this example is: the average monthly income of Filipino families who belong to low-income bracket is not equal to 7,500. Notice that the null hypothesis is expressed using the equal symbol, while the alternative hypothesis is expressed by not equal symbol because the claim or conjecture does not specify any direction. Example number 2. The average number of hours that a person who developed a COVID-19 symptoms improved without treatment is more than 2 weeks. Null hypothesis. The average number of hours that a person who developed a COVID-19 symptom improved without treatment is 2 weeks, or mean is equals to 2. Its alternative hypothesis is the average number of hours that a person who developed a COVID-19 symptom improved without treatment is more than 2 weeks, or mean is greater than 2. Observe that the alternative hypothesis is expressed with greater than symbol because the claim or conjecture specifies to use the more than or greater than symbol. Sample number 3. The average number of hours that side effects of COVID-19 vaccines last is less than 48 hours. Null hypothesis. The average number of hours that side effects of COVID-19 vaccines last is 48 hours, or mean is equals to 48. Alternative hypothesis. The average number of hours that side effects of COVID-19 vaccines last is less than 48 hours, or mean is less than 48. Observe that the alternative hypothesis is expressed with less than symbol because the claim or conjecture specifies to use the less than symbol. Sample number 4. No more than 60% of the registered voters in BATAAN voted in the local election. Null hypothesis. No more than 60% of the registered voter in BATAAN voted in the local election, or mean is less than or equal to 60. Alternative hypothesis. More than 60% of the registered voters in BATAAN voted in the local election, or mean is greater than 60. Observe that the alternative hypothesis is expressed with greater than symbol because the claim or conjecture is specified to use the less than or equal to symbol. Conclusion. Based on the examples, the null hypothesis is always expressed with equal symbol. It is always a statement that the parameter is equal to a specific value. In contrast, the alternative hypothesis is expressed with not equal to, less than, or greater than symbols, depending on the given conjecture or claim. Lesson 3. Types of tests. Statistical tests may either be directional, one-tailed, or non-directional, two-tailed. We can determine whether a test is directional or non-directional by looking at how the alternative hypothesis is expressed. Number 1. Directional test or one-tailed. A test of any statistical hypothesis where the alternative hypothesis is expressed using less than or greater than, since the critical or rejection region lies entirely in one tail of the sampling distribution. While the non-directional tests are the two-tailed, a test of any statistical hypothesis where the alternative hypothesis is written with not equal sign, since there is no assertion made on direction of the difference. The rejection region is split into two equal parts, one in each tail of the sampling distribution. These are the graphical representation of two-tailed tests and one-tailed tests. Directional one-tailed left tail. The probability is found at the left tail of the distribution. Directional one-tailed right tail. The probability is found at the right tail of the distribution. While non-directional or two-tailed, the probability is found on both tails of the distribution. Sample number 1. The average daily allowance of college student is less than 200 pesos. Null hypothesis. The average daily allowance of college student is 200 pesos. mean is equals to 200. Alternative hypothesis, the average daily allowance of college student is less than 200 pesos. Mean is less than 200. Graphical representation of the alternative hypothesis. This is directional test or one-tailed test. Specifically, this is left-tailed test because less than symbol was used in expressing the alternative hypothesis. Sample number 2. The average daily allowance of college student is greater than 200 pesos. Null hypothesis. The average daily allowance of college student is 200 pesos or mean is equals to 200. Alternative hypothesis. The average daily allowance of college student is greater than 200 pesos or mean is greater than 200. This is also a directional test or one-tailed test. Specifically, this is right-tailed test because greater than symbol was used in expressing the alternative hypothesis. Sample number 3. The average daily allowance of college student is 200 pesos. Null hypothesis. The average daily allowance of college student is 200 pesos or mean is equals to 200. Alternative hypothesis. The average daily allowance of college student is not 200 pesos or mean is not equals to 200. Observe that the alternative hypothesis expressed is using not equal symbol. Thus, the test is two-tailed. Lesson 4. Type 1 and Type 2 errors. Type 1 error occurs when we reject the null hypothesis when it is true. It is also called as alpha error. Type 2 error occurs when we accept null hypothesis when it is false. It is also called as beta error. These are the graphical representation of Type 1 and Type 2 errors, showing the region of Type 1 error and the region of Type 2 error. Better understanding, let us put it in an example. Brian is starting his own food cart business and he is choosing cities where he will run his business. He wants to survey residents and test at 5% level of significance whether or not the demand is high enough to support his business before he applies for the necessary permit to operate in his selected city. He will only choose a city if there is a strong evidence that the demand there is high enough. We can state that the null hypothesis for this test as null hypothesis, the demand is high enough. Number 1 question. What would be the consequence of a type 1 error in this setting? Letter A. He doesn't choose a city where demand is actually high enough. Letter B. He chooses a city where demand is actually high enough. And letter C. He chooses a city where demand isn't actually high enough. The type 1 error is the first statement because he rejected the true null hypothesis. Number 2. What would be the consequence of a type 2 error in this setting? Letter A. He doesn't choose a city where demand is actually high enough. Letter B. He chooses a city where demand is actually high enough. And letter C. He chooses a city where demand isn't actually high enough. The type 2 error is the third statement because he failed to reject the false null hypothesis. Number 3. What is the probability of the type 1 error? The probability of the type 1 error is 0.05 because it is the level of significance use. Level of significance. Level of significance is the probability of committing type 1 error. It is denoted by the Greek alphabet alpha. The value of alpha tells us the probability of making an error in rejecting the null hypothesis when it is true. This depends on the risk or degree of confidence of the researcher is willing to take in committing type 1 error. 0.05 and 0.01 are the commonly used level of significance. The level of significance should be set before testing the hypothesis. A 0.01 level of significance means that the researcher is willing to take 1% error in deciding. It also implies that the researcher is 99% confident to make a right decision. Likewise, a 0.05 level of significance means that the researcher is willing to take 5% error in deciding. It also implies that the researcher is 95% confident to make a right decision. Lesson 5. Accepting or rejecting the null hypothesis. The rejection region or critical region is the set of all values of the test statistic that causes us to reject the null hypothesis. The non-rejection region or acceptance region is the set of all values of the test statistics that cause us to fail to reject the null hypothesis. The critical value is a point or boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. For better understanding, let us put it in an example. According to a survey, the average daily usage of social media worldwide of global internet users amount to 142 minutes per day. Sophia used a 0.05 level of significance. Sophia conducts her own survey among her friends to find out if their time spent on social media is significantly higher than the global survey. This is the table Sophia's friends and their respective time spent on social media. Claim A. The average daily usage of social media of her friends is the same as the global average usage. Solution. Step 1. Identify the given. Population mean is equals to 142. Sample size is equals to 10. Sample mean, standard deviation, and the t-score is unknown. Step 2. Solve for the sample mean. To solve for the sample mean, add all the given and divide it by 10. So sample mean is equals to 152. Step 3. Solve for the standard deviation. Process in solving standard deviation is already discussed in the previous lesson. Therefore, standard deviation is equals to the square root of 354.8 or 18.84. Step 4. Solve for the t-value. Using this formula, bar x minus mean over s over square root of n. Substitute the given. Then perform the operation. So we have t is equals to 1.6. Step 5. Determine the critical value using the t-table. Find first the degree of freedom using the formula df is equals to n minus 1. So we have 10 minus 1. degree of freedom is equals to 9. Use the t-table to find the critical value. We have df is equals to 9, and we have 0.05, so we have 1.833. Step 6. Sketch a t-distribution curve and label showing the rejection area, the shaded part, and the non-rejection area, the critical value, and the computed t-value. As we can see, the computed value is less than the critical value. Null hypothesis. The average online usage of her friends is the same as the global usage. Alternative hypothesis. The average online usage of her friend is higher than the global usage. The computed t-value is at the non-rejection area. We fail to reject the null hypothesis. Sample number 2. Sketch the rejection region of the test hypothesis with critical values of positive or negative 1.753 and determine if the computed t-value of negative 1.52 lies in that region. Steps in doing this example. Draw a t-distribution curve. Since there are two critical values, it is a two-tailed test. Locate the critical value and shade the rejection regions. The computed t-value is at the non-rejection region. Therefore, we fail to reject the null hypothesis. Evaluation. Now, open your modules on page 13 to 16. That's all for today. Thank you for watching.